Hello, welcome to the garage. I performed a minor brain surgery and removed the processor board from Toyota Prius Gen 3 inverter, and today I will be looking at a Damien Maguire processor board design, and I will be ordering it from JLC PCB website. Let's get started. I will start from downloading a design that Damien Maguire produced for the Prius Gen 3 inverter. So I'm on Damien's GitHub repository and I'm going to the Prius Gen 3 inverter. So I will download the whole repository, just download the zip file there and navigate to the folder and extract all files. So in this repository we have a number of designs, including the small board, the mains inverter, but we are interested in 1C board. So this is the board that allows to control MG2. If I look at the schematic, rotate it clockwise, so it has a central processor to control MG2. It has a power supply module, temperature sensor filters, charger CAN bus, ESP Wi-Fi module, inverter CAN bus, PWM drivers, so those will be driving IGBT transistors, and EVSC signals, as well as so we should have a processor. This is very important part, so the resolver excitation circuit, which I'll talk about this in a separate video, and yeah, supposed to be Atmega to control the charger. At the moment I can't find it. Yeah, this is the one, so it's Atmega 328P, so this is to control the charger. So there is another board available on the GitHub, it's a V1D. So this board, it's a dual board, so it has two processors, allow you to control MG2 and MG1, but I want to start from a simpler version from 1C and try it and see how it works, and then perhaps move to 1D design. Okay, next I'm going to the JLC PCB website and I will upload the design. So if I go to quote now and add a Gerber file, so I'm on a 1C board and I need to upload the Prius G3. Uploading the Gerber files. And here we go, we have our board. So this is the top side, this is the bottom side. It's a 4-layer design, 154 by 154. So the minimum quantity you can have is 5 PCBs, so delivery format single PCB. So I'm gonna leave all of this as a default. I'm gonna go for green because it's actually fastest and the cheapest. So if you want to go for other colors, so it will either be slower or will be extra charge. Here, for example, you see there's a special processing fee for white. Black is the same, but it's 2 more days, so I'll go for green. Okay, so now I'm going to choose SMT assembly option. So I'm going to go for 2 boards and I will assemble the top side. So tooling holes added by JLC PCB. I'm going to next, and at this stage we need to add bill of materials, which is this one, and placement file for the pick and place machine. So I'm going to the bill of materials, and Damien is kindly provided the bill of materials as well, so which is this file here, and it's now uploaded, and I will add a placement file. So it would be this one, and I'm going to next, and now it's loading the design, and it will identify the parts that are present and the parts that are missing. As we can see, there's one part is missing. Let's see what else is there. Yeah, everything is in place except this part. So let's have a look, see what we could do about this part. So it's Sunlord power inductor. So it's a 10 microhenry inductor, 3.2 amps, 5.2 by 5.4. Right, so let's see whether we can find 10 microhenry inductor. So I'm going to the parts library and I type 10 microhenry, and so we have number of options. So that's an inductor here. So it looks similar, but I think it's a different footprint. It's 4.2 by 4.4. About this one, it's much larger footprint. Oh, that one looks reasonable. So it's 5.2 by 5.4, 10 microhenry, and we do have 14,000 of them in stock. Now let me just double check. So this one is 3.2 amps, and this one is 3.2 amps, so it's perfect. So that's the part we need. So if we go back here and go search and type in this part and press search, so it's found this one. Let's just make sure it's correct. 10 microhenry, same footprint, 3.2 amps. So that's a good one. So we're going to select this, and now we have all the parts available. We're going to next, and now a JLC PCB website suggesting a parts placement check. If I use mouse wheel, I can scroll and check the placement. I mainly check the pin 1 positioning. It's right, because sometimes they have rotation problems. They calculate rotation different for different packages. I use KiCad, and quite often it's wrong. But in this case, it looks to be, everything seems to be fine. So I'm happy with that, and check out the parts list, and I can save it to the card. Okay, so that's done. And next thing I want to do is I want to actually upload the Ampseal connector. So Damien provided as well the plots for the Ampseal connector. It's to have a connection for the inverter, and I will upload that. So in this case, this is a 2-layer PCB. Just to interconnect between the Ampseal connector and IDC connector on the board. Oh no, it's actually 4 layers. Sorry. Okay, so just go. In this case, I'm only going for the board. So I'm happy with my selections. Quantity 5, and we don't need SMT assembly, so we're just going to save to the card. And now we can go to the checkout. While I'm waiting for the boards, I opened the inverter. It wasn't really easy, not to crack, I should say. I had to use sharp carpet knife to get in between the sealant and crack open the top lid. I disconnected connectors from the top of the board and from the side of the board as well. I had to remove the rear frame. This is where the current sensors are mounted for MG1 and MG2. So this frame covering up the board on the back. You could see me undoing 7mm bolts that are securing the frame to the inverter. Here we go, the board is out, and now we have an empty space waiting for the new brain. And the last thing I had to do is actually to source the connectors, as a JLC PCB does not install connectors on boards they manufacture, so I had to source the connectors separately. I found most of them from Farnell website, except this one. This one proven to be a bit of a tough one to find. So, but surprise, surprise, I found it on AliExpress website. So I ordered 5 pieces of this type of connector from AliExpress. I'm hoping they will arrive sooner or probably the same time as the boards.